When touch time is less than 10% of the elapsed time, it is inevitably the case that more than 90% of the time the work order spends in the plant, it is sat in a queue doing nothing of any use. This means we can safely delay or choke the entry of raw materials into the plant, and that the only thing that will happen is that the level of queuing will be reduced. This happens because each work center in the plant continues to process work orders from their queues while the release of raw materials is stopped. Each day that passes in the choke period, work orders are completed and leave the plant while no new work orders enter the plant. This means inventory levels drop and queuing is reduced. There are no negative effects from doing this. Customer orders are still accepted and according to the lead times to which they are accustomed. It's just that those work orders do not enter the plant. In fact, choking the release of raw materials has many positives, including inventory is reduced by at least 50% versus the current level. Lead time is reduced by at least 50% of the current lead time quoted to the market. Throughput goes up by at least 30%. Visibility on the shop floor is greatly improved. Management and prioritization of the shop floor becomes significantly easier. Unhelpful local optima behaviors are reduced, and due date performance improves significantly, often to above 90%. So this begs the question, for how long should we delay the release of raw materials to the plant? The rule we follow here is to reduce the time buffer by 50% of the current quoted lead time, or in other words, we only allow raw material half of the time we currently give it to move through the plant. This should be sufficient to move us from the chaos of the right side of the curve to the calm of the plateau. Any less than 50% and you run the risk of not seeing any change, and from experience this is a very real risk in implementation. I'll have a lot more to say about this in part 2 of On Time in Half the Time. On the other hand, the 50% reduction is not so much that it takes us to the other extreme of the left side of the curve. 50% is about right, not too little and not too much. Okay, sounds interesting, but how do we do that? Choking the release relies on us distinguishing between the lead time that we quote to the customer and the lead time that we allow for production. They don't necessarily have to be the same thing. The quoted lead time is the time that we typically indicate to the customer that their order will take and that we use to calculate the due date committed to the customer. This clock starts ticking upon receipt of the order until we hit or miss the due date. The production lead time is the time we allow work orders to make their way through the plant. They do not have to be the same thing, but in practice in most plants they are. Orders are received and they are released to production immediately. Why? Well, if you continually struggle to ship on time, the obvious but unfortunately wrong answer is to start production as soon as you can, in order to give yourself the best possible chance of completing the order on time. This logic sounds compelling, and in fact it is true in isolation. But the unfortunate reality is that the work order is not in isolation. It coexists with numerous other work orders in the plant, many of whom are queuing to be processed by the same resources. So, let's be smart and do something different. If we distinguish between the quoted and production lead times, we can continue to quote our existing lead times to our customers and accept their orders while holding back those orders from being released to production for half of the quoted lead time. This will move the plant from the chaos to the plateau, dramatically reducing queuing in the plant and allowing work orders to flow much more quickly through the process and finish on time. This diagram explains the process in more detail. You'll remember from video 2 that our little plant typically has a 30-day quoted lead time. When a customer places an order, the plant confirms the due date as today's date plus 30 days. So, for example, if an order is placed on the first day of the month, the due date is 30 days later. If it's a month with 31 days, the order should be shipped to the customer on the 31st. If it's a month with only 30 days or it's February, it'll be in the early part of next month. You get the picture. Now, what happens next is important to understand. The order is not released to production. Instead, it is added to a raw material release schedule which itemizes the accepted customer orders and the day the material should be allowed into the plant. Remember, releasing inventory too soon creates unnecessary queues in the plant, so instead we hold back the work order until the correct time as defined by the raw material release schedule. The production lead time is half of the quoted lead time, so if our quoted lead time is 30 days, the PLT must be 15 days. That means for an order accepted on the first of the month, it will not be released to production until day 16. This is what we call the choke, holding back raw materials and not releasing it to the plant. Again, this prevents unnecessary queuing in the plant and moves us from the chaos of the right side of the curve to the relative calm of the plateau. The next day is the second of the month and the process continues. When a customer places an order, the due date is given as 2 plus 30, which equals a due date of 32 days' time. The raw material release date is calculated as the due date minus the production lead time. An important note here. Why is the raw material release calculated by subtracting the production lead time from the due date instead of the date the order is accepted plus the production lead time? That's because sometimes a customer will want the order delivered later than the due date you are offering, and you do not want the raw material to go into the plant any sooner than is necessary. So, for example, let's imagine today is the second of the month. A customer places an order and you offer the due date of 32 days' time. The customer declines this, explaining that we don't actually need the product until day 45. You then tell the customer that's okay, you accept the order and commit to a due date of day 45. How now should you calculate the raw material release date? Well, if we follow the formula of date the order is accepted plus production lead time, our raw material release date for this order is day 17. If we follow the formula as I've recommended, i.e. due date minus the production lead time, it equals day 45 minus 15 days, which equals day 30. See the difference? The recommended formula releases inventory on day 30, 13 days later than the incorrect method. The later release is exactly what we want. We don't want inventory going into the plant too soon. It just causes queues, which elongate the manufacturing lead time and distorts priorities at the work centres. That's why material release should be calculated due date minus the production lead time. The same goes for customer orders which you choose to accept within the quoted lead time. I don't typically recommend this unless you are using your superior operational capability to segment the market and earn premiums for delivering the order faster than any competitor can. I talk a lot about this in part 4, so I recommend you watch this video if you want to learn how to turn the superior operational capability SDBR gives you into a decisive competitive edge. However, in real life, we sometimes have to accept urgent orders to help out a customer or make up for a mistake, etc. etc. So what happens in this case? Let's say today is the second of the month and a customer calls us. They have forgotten to place an order. They're a good customer, we're friends, so we need to help them out. They tell us they need the product in 22 days instead of the normal 30 days quoted lead time. We don't want to put production under unnecessary stress, and we will if we don't give them enough time to process the order. We will send them to the left-hand side of the inventory curve. So instead, we calculate the raw material release date as due date minus the production lead time, which in this case is 22 minus 15, which equals day 7. So for this order, we will release the raw material on day 7 instead of day 17, which we would have done for an order with a normal quoted lead time of 30 days and a production lead time of 15 days. This prevents inventory being released to the plant too late or too soon and maintains the production lead time at the usual 15 days. This way, we will be able to help out our customer, who will think we're great when we deliver early, and keep production happy. This process then becomes a permanent feature of the production management system for the plant. Orders are accepted and due dates are given based on the quoted lead time. The work order is then held back or choked until the raw material release date determined by the due date and the production lead time. This mechanism not only drains the plant of unnecessary inventory at the start of an SDBR implementation, but prevents the plant from being flooded again with more inventory than is strictly necessary in the future. Okay, so that is the first element of the simplified drum buffer approach. We choke the release of raw materials to eliminate queuing and prevent the plant flooding in the future. Let's now turn to the second aspect of SDBR, which we are going to implement simultaneously with the choke.